Hello class. So we're going to start matrices. This chapter is the intro to matrices. And matrices, for your purposes as business majors, is mostly just tables, is what you could think of them. Computer stores them as a matrix. Okay, so what we're going to do is we're going to learn to do operations on matrices, from adding and subtracting and multiply to other techniques. So the first thing is to look at an example. So we have these matrix. We have two plants, plant A and plant B. Plant A in 2021 made 12 toasters, 33 mixers, and 40 blenders. In 2022, it made 15 toasters, 30 mixers, and 42 blenders. In 2023, it made 16 toasters, 29 mixers, and 39 blenders. And we can represent them as a matrix, which I've done here. Okay. So matrix A, representing plant A, can be written as this matrix, where you have columns and rows. So here's the rows. Okay. And you have columns. Okay, column 1, column 2, column 3, row 1, row 2, row 3. And then we can do the same with matrix B. So matrix B in 2021 made 25 toasters, 16 mixers, 22 blenders. 2022, it made 34 toasters, 16 mixers, and 24 blenders. And 2023, it made 29 toasters, 14 mixers, and 21 blenders, and we represent that as matrix B right here. Now, what we're going to do is we're going to perform operations, okay? So a matrix can be thought of as a variable. Now, when we denote matrices as variables, they're always capital letters. So notice that in these, that these two matrices A and B are capital letters, okay? Non-matrix variables are lowercase letters, but matrix variables are capitals. Now, matrices also have rows and columns, so the rows are first. So we'll represent A is a 3 by 3 matrix, so it has 3 rows by 3 columns. So it's 3 rows by 3 columns. Okay. So here in this example here, matrix A is the matrix 2, -1, 5, 0, 4, and -2. So it's this matrix here. It has 2 rows and 3 columns. So this is a 2 by 3 matrix. Matrix B is exact opposite, it has 3 rows and 2 columns right here. So 3 rows and 2 columns. Okay. Now we can represent single elements from a matrix by a lowercase letter. So if we want to know for matrix A what the 1, 3 is, so here in the big matrix A above, this matrix A here. If they want to know what A3 is, so A, this is the row, this is the column. So looking for row 1, column 3, that gives you this element is 40. It's where the 2 rows and the row and the column intersect. So the element A13 is the number 40. What about the element B23? So in big B, B23, so here's B2, here's 3. Well, they intersect at 24. So that would be 24, okay? So again, these are your rows, these are your columns, okay? We can also have what's called square matrices. So square matrices are when they have the same number of rows as columns. So you can have a square 1 by 1, a square 2 by 2, square 3 by 3, etc. Square matrices are quite important, and we do a lot with them later. We also have what's called transpose. So you can take a matrix and transpose it. All you're doing is you're making the first row be the first column and the second row the second column, etc. So B, this matrix B here, highlighted right here, if we're to transpose it, we'd switch. This row would become the first column. The first row would become the first column. The second row would become the second column. That's all transposing does, is it makes a row a column. We also have identity matrices. So we have the additive identity. Additive identity matrix is just a matrix with all zeros. So here is an additive identity matrix for a 2 by 3 matrix. Here's one for a square 2 by 2 matrix. Okay. We also have multiplicative identity, but we'll cover that later in the next section. In order to add two matrices, what you do is you add the corresponding elements that match up. So if we have this matrix A here, A is 1, -3, 4, 2, 0, -1, and B, which is -2, -1, 5, and then 0, 4, -2, you're going to add them. So what you're going to do is you're going to add the first element in the first row and column in A with the first element in the first row and column in B. So you're going to add 1 and 2. Okay, then we move here. We're going to add -3 with the -1. And then 4 with 5. Then we come down here to this 2. That 2 we're going to add with a 0, which is what we do here. Then this 0 we're going to add to the 4, which is what we do here. And this -1 you're going to add -2, which is what we do here. And when you add the individual elements, you get another 2 by 3 matrix. So A plus B is 3 minus 4, 9, 2, 4, -3. What about subtracting? Well, subtracting is done the same way. So what you're going to do to subtract A and B, you're going to take this element first and subtract this. So 1 minus 2, which is what I did here. Then -3 minus a -1. Well, minus 1 makes it plus, so -3 plus 1. And then 4 minus 5. Oh, that is wrong. That should be 4 minus 5. Okay. Delete that. That's 4 minus 5. That makes that a -1. So that's my typo. Okay. And then 2 minus 0, which is 0, and then 0 minus 4, which is -4, and then -1 plus 2, which is +1. Okay. We also have what's called scalar multiplication. Scalar multiplication is we take a matrix and you multiply it by a constant in front. So if we take matrix A, 1, -3, 4, 2, 0, -1, and we multiply it by 3, we're going to multiply each individual element by 3. So that's what I'm doing here. 3 times 1, -3 times 3. 4 times 3 is 12. 2 times 3 is 6. 0 times 3 is 0. And -1 times 3 is -3. And you get that. So that's called scalar multiplication. So 3A. Multiply A by 3, which means we multiply every element in A by 3. Okay. So that's what is in this intro to matrices. Let's work this out. So first, we have the matrix A, 15, 4, -3, 0, 1, 18, and B, -2, -1, 19, 5, 3, -2. We want to subtract them. So draw a matrix. First, I need this element. So I'm going to take the 15 minus a 2. So 15 minus a 2, which is +2. Then this next element is 4 minus a -1, so 4 plus 1. The next element's -3 minus 19, so -3 minus 19. And then I go down to the second row, 0 minus 5, so 0 minus 5, 1 minus 3, 1 minus 3, 18 plus 2, because negative. Okay, that'll give us a matrix 17, 5, negative 21, negative 5, negative 2, and 20. Okay, so that's A minus B. What about A transposed? Well, A transposed, if we go back to A, this row is becoming the first column. So it's the matrix 15, 4, negative 3. Then this row becomes the next column, 0, 1, 18, and that's A transpose. So it's now a 3 by 2 matrix. Okay, find A23 and B23. So A23 is the second row and third column. So second row, third column, that's 18. So A23 is 18. What about B12? That's the first row and B second column. So first row, second column, that's negative 1. So that's negative 1. Okay. What about A times or minus 2B? So then we're going to go A. Let me scan out. So that's A is 15 minus, so 15. So first 15 plus 4. It's plus 4 because it's negative 2 times negative 2. So it's plus 4. And then we have 4 minus 2. Well, it's 4 minus minus 2. And then negative 3 minus 38. And then second row, 0 minus 10. Then 1 minus 6. And then 18 minus, or plus 4. 18 plus 4. Okay, so when we do that, we're going to get the matrix 19, 6, negative 41, negative 10, negative 5, and 22. Okay. Find A transpose plus B. Well, here's the thing. A transpose, this A transpose is a 3 by 2 matrix. B is still a 2 by 3 matrix. You can't add matrices unless their size is the same, their shape. And while we could add A and B together because they were both 2 by 3. So this is 2 by 3 and this is a 2 by 3. When you transpose A, it becomes a 3 by 2, which means it's not same shape. So you can't actually add these. So no solution. Okay. If two matrices are not the exact same size, you can't add them. Okay. So if we want to find the total production of the word problem at the beginning, we want to add these two plants. So we're going to add them. So I have the matrix. So we want to know what matrix A plus B is. Well, that would be 12 plus 25, which is 37. 33 plus 15, which is 48. 40 plus 22, which is 62. 15 plus 34, which is 49. 30 plus 16, which is 46. 42 plus 24 is 66. And the last one, 16 plus 29 is 45. 14 plus 29 is 43. And then 21 and 39. So 39 plus 21 is 60. Okay. So the total productions for those two plants over the years is this matrix. And this is often something you're going to do. Now, your TI calculator can actually do matrix arithmetic. It can do all this stuff for you, from addition, subtraction, transposing, multiplication. So I have a link here that you can watch videos for doing that. It's right there that I highlighted. Okay, so here is Intro to Matrix. Talk to you later. Bye.